One way to make a solution is to dissolve two liquids in each other. All right, so we have a couple of definitions. We have miscible and we have immiscible. Miscible is where we have two or more liquids that are infinitely soluble in each other, which means I can mix them in any proportions as much as I want together, they will go together. Immiscible, these are liquids that are not soluble in each other. They'll form separate layers. So immiscible, a good example of that is oil and water. They are immiscible. They do not mix. Okay? And so when we have our liquid and liquid, again, we've got our solute-solute interactions, we have our solvent-solvent interactions, and in order to get the solution, now we have to have solute-solvent interactions. And so water has very strong hydrogen bonding. Methanol is a really small little molecule that is an alcohol. So it's got a single carbon side chain on it. Okay? And then it's got a little polar head like water. And then, of course, water is our H2O. All right, and so that OH head on methanol will hydrogen bond, which means we can also hydrogen bond the methanol with the water. And so we get good mixing there. Methanol and water are miscible with each other. Okay, so we can look at some different hydrocarbons or not different hydrocarbons, different alcohols, and then the hydrocarbon hexane. So hexane is 1, 2, 3, 4, 5, 6 carbons with the hydrogens. Okay. Now the thing with the alcohols is they all have that polar head on them. However, once we start making that side chain longer and longer, it gets harder and harder to get to that little head there. And so as we increase the carbon side chain, we decrease the solubility in water because now we've got this big carbon side chain in the way. If we have something that is infinitely soluble, this is miscible. Okay, and so methanol, so we're going to look at this. We're going to do number of carbons. Okay, methanol has 1 carbon, ethanol has 2, propanol has 3, butanol has 4, pentanol has 5, and hexanol has 6. So as we increase those carbons, what's happening to our solubility in water? Well, between 3 and 4 carbons, we go from miscible to a decreased solubility. And by the time we get to hexanol, which has the same number of carbons as hexane, that's why they both have hex in them, now we've greatly decreased the solubility. However, it doesn't take a whole lot to get the miscibility with hexane. Okay, if I look there, I only need to increase my carbon side chain to 2 carbons, and now I'm completely miscible in my hexane. Okay, so hexane is a straight chain hydrocarbon. It's pretty boring. It is nonpolar. And so when I look at something like hexanol, where I have my 1, 2, 3, 4, 5, 6. Okay, what's happening here is this end is nonpolar, whereas this end is polar. Okay, and so that's where we get the good miscibility with hexane. But because we've got such a long carbon side chain, we lose a lot of that solubility in water. Okay, and so when we think about different solvents to use for things, okay, whether it's for making a liquid in liquid solution or even trying to dissolve a solid, remember, like dissolves like. And so a lot of labs will have lists like this just to help remind you of what are your polar solvents and what are your non-polar solvents to help you make more informed choices as you try to figure out, all right, what am I going to try to dissolve this stuff in? Okay, so let's think about this. Okay, let's hear what is miscible. Water and ethanol. Well, we just saw that water and ethanol are miscible, okay? We have to get up to 4 carbons before we lose the miscibility in water. And ethanol has 1, 2 carbons, so we're still below that, so we're good there. Okay, hexane again is that 6 carbon long chain. Now xylene, okay, what you don't see are carbons around the edge. I drew one too many because we're bonded to the CH3. There we go. Okay, so around the carbons, we also have the hydrogens. So xylene is roughly the same size lengthwise as hexane is. And xylene is also a hydrocarbon. It only has hydrogens and carbons. So xylene is also nonpolar. So think about this for a second. If hexane is a long straight chain hydrocarbon that's nonpolar, and xylene, it's got the ring in the middle of it, but it's also nonpolar, would you expect hexane and xylene to be miscible in each other? Well, hopefully you said yes, they should be. Okay? All right, now let's think about ethanol and xylene. Let's think about some deductive reasoning here. We know that from the previous slide that we looked at, we know that ethanol and hexane are miscible in each other, okay? We just decided that hexane and xylene should be miscible in each other. So if ethanol is miscible with hexane and xylene is also miscible with hexane, should ethanol be miscible with xylene? It should. From deductive reasoning, we should get miscibility between those two as well. So we're going to go with E, all of the above. All right, so those are our liquid in liquid solutions.